前方做准备。
The siphon effect is everywhere around us, from that puddle in the toilet every time flushed, to changing water for your fish tank, and even how we move water from one lake to another. We can see that the siphon effect is evident everywhere. And it really was that fish tank that got us curious. What would happen if we moved a siphon into space? Would it still work, or would it look different somehow? And really, in a broader sense, we're talking about how every single aspect of our lives can be changed by simply moving to space. We're Team A11 AstroPower, and the title of our experiment is Fluid Dynamics and Microgravity. Our process is really simple. We consider the constraints aboard the space station, which include safety and the materials available, which fortunately, a siphon is super simple. Using two simple items, a container with water and a simple tube that we sort of inside the container out, we can create a simple siphon. So this is how our experiment would work. There are 2 parts to our experiment. The first is how you would use a straw as a dropper, as demonstrated here. Using atmospheric pressure, we can pick water up with a straw. And this is the effect that we'll use to kickstart our actual experiment, the siphon, which is out now. So when we put the shorter end of the straw into the water, and then when we release our thumb from the other side, the water should be able to go to the top of the siphon, and gravity would do its job and pull the water the rest of the way, as demonstrated here. This is how a siphon should work on Earth. So really, how does a siphon work? One of the leading theories about how the siphon effect works is the intermolecular forces between water molecules. These water molecules will form a chain between them. So when the first few water molecules have passed the top of the siphon, gravity will be able to pull it the rest of the way down. And it will continue to pull the chain down, sort of like how you would pull a rope over a wall. And now about that drop, and on the ISS, since there's no gravity to continue to pull that chain down, we believe that the water would stop as soon as the pressure inside the straw and the volume are equalized. And about that dropper, since the cabin pressure aboard the ISS is kept at a very similar level to how it is on Earth, we believe that, yes, we'll still be able to pick up water with just that simple motion. However, the liquid will not flow out when you release your thumb, since on the ISS, there's no gravity to do so. And so that's it for our experiment. And it's an experiment that we hope will invite investigation to how every aspect of our lives could be changed if we were to live in space. Simply the lack of gravity can change so much about how we live our daily lives. Thank you.